Hi guys, we're continuing our lesson here on types of roots and solving equations using factoring. So let's take a look at the next page of the lesson where we have some that are already been factored for you. Hooray, that's so wonderful. Now, looking back at the previous example, you might have noticed some similarities between where the x-intercepts were and what the factored form looked like, because we looked at three factored forms. Let's take a step back here for a second and take a look at what those were. So if you'll see here, we had x plus 3 and x minus 1. And you'll notice the solutions, that is the x-intercepts. If this was a 0, it would be asking for the solution. The x-intercept is minus 3. Oh, look at that, plus 3 to minus 3. And the minus 1 turns into plus 1. Oh, look at that. So the solution would have been minus 3 plus 1 for the value of x that makes this whole thing equal to 0. And we'll look at that algebraically in a second. And then also notice here we have x, there's just an x by itself, right? And so we could think of that as x minus 0. If that turns into 0, it would be an answer that makes this whole thing 0. We can test it, right? Put 0 in here, and you get 2 times 0 times, who cares? It's times 0. It's all going to be 0. And 0 equals 0. Or minus 5. So you plug minus 5 in here, and negative 2 times minus 5 is positive 10. All right. And then 10 times minus 5 plus 5. Oh, that's 0. So positive 10 times 0, still 0. So there's our solution. And then over here we have minus 5. If we plug that in, we get minus 5 plus 5 is 0, and 0 squared is still 0. So notice these x-intercepts are giving us the solutions, and from factored form, you can actually almost see in the factored form what those answers are going to be. So let's take a look at what that looks like algebraically. So here on the next page, all we do is once we have it in factored form, it's a multiplication of some things. That's what factored form does. It puts it into the form of multiplying. So what we do is we think about the logic of how multiplying works, right? If I multiply something by 0, it doesn't matter what the other number is. The answer will be 0. So we look at this in two separate cases, where this first binomial could be the 0 that makes the whole equation 0. Or the second one could be. So that's how I'm actually going to approach it. So I'm going to say x minus 3 is the thing that makes it 0, or x plus 5 is the thing that makes it 0. And if that's the case, then I just solve each one separately. So x minus 3 equals 0. Well, that's x equals positive 3. There's one root for us. Or x plus 5 equals 0. Okay, well, move the 5 to the other side or subtract 5 from both sides, whatever your system of logic is, and we get x equals negative 5. That is all there is to it. So you factor it. Once it's in factored form, you take each factor and you set it equal to 0. Notice how the negative binomial with a negative in it became positive root. The binomial with a plus in it became a negative root. I'm not going to do all these for you. I'm going to do a couple of them so you can see, and then the rest of them is up to you. There are also some homework questions posted to the Google Classroom for you to try out. So let's try this one, and let's do D actually. D is a hard one-ish. So we take each factor, so 3x plus 5, and set it equal to 0, and we solve that. I'm going to set both of them up at once because I would forget to go back if I didn't do it at once, but then I'm just going to solve one at a time. Okay, move the 5 to the other side. I got 3x equals minus 5. Then I'm going to divide both sides by 3 to get x equals negative 5 over 3. And I'm going to leave that answer as a fraction. I don't like decimals myself. Other teachers in the future might say, give me an approximate answer, round it to 2 decimal places. Not me. I want minus 5 over 3 as my answer. That's what I like. Move the minus 2 to the other side. It becomes plus. So I get 5x equals plus 2. Divide both sides by 5, and I get x equals 2/5. So there's my two solutions. I'm going to put a box around them so they're nice and easy to read, as should you. So there they are. Now, we may have to do the factoring ourselves first. So in the case where we actually said solve the following equations, we're going to have move everything to one side of the equal sign so that it is equal to 0. And then common factor out anything that I can, if it's possible, then use the factoring techniques that we've already learned to factor. So we want them in a form like this. So again, remember, we're looking for, excuse me, two numbers that multiply to make 14. but also add to make 9. The nice thing about this is that the leading coefficient here in front of the x squared, it's a 1. So as soon as we find those two numbers, we can throw them into the brackets and we're done solving. We're done factoring, excuse me, then we can go on to solving. So those two numbers, I can make a quick list, 1 and 14, 2 and 7, that's all of them. So some of these have to add or subtract to make 9. 2 and 7 add to make 9. All the signs agree, so it's 2 and 7. And so now I'm just going to say x plus 2, x plus 7, still equal to 0. Notice I replicated the equals 0 here. Very important. And now I can separate it out to say x plus 2 equals 0 or x plus 7 equals 0. So I get x equals negative 7 and x equals minus 2. I put boxes around them, and there's my answers. Let's go on the slightly more challenging. Let's do this one here, D. So for D, I'm going to move the 15 to the other side. So I get 6x squared minus x minus 15 equals 0. And now, remember, I find the product of these two is the product number. So two numbers that multiply to make 6 times 15, and it's 3, it says 90. I hope that's right. Yeah, that's right. It's actually minus 90. There it is. And the same two numbers that multiply and make minus 90 is going to make minus 1. So let's make a list of factors. 1 and 90, 2 and 45, 3 and 30. I know they have to be close together because they have to add or subtract to make minus 1. What else we got? 4 won't work. 5 will work. It's going to be 5 and 18. No, that's no good. Would 6 work here? Yes, 6 and 15. Those are the two we used to make it. 7 doesn't do anything. 8 doesn't do anything. 9 and 10. Oh, why didn't I start there? Oh, well. As I can see, these are really close together. So if it was a minus 10 and a plus 9, they would add to make minus 1 and multiply to make what I want. So 9 and minus 10 are my two numbers. And then remember how we do this? We factor by grouping. So we split this middle term into minus 10x plus 9x, and then we reproduce everything that was around it. We factor the first two, so what's common? 2 and x. 2x, and I get 3, oh my goodness, I made a mistake. 2x, and I'm left with 3x minus 5, and then what's common to the second two is a 3, so plus 3, and I'm left with 3x minus 5. Then factor the binomial out, so 3x minus 5 and 2x plus 3 equals 0. And now I can solve each of these individually. So 3x minus 5 equals 0. I have no room here. I'll do this over here. 3x minus 5 equals 0 gives me, move the 5 over, 3x equals 5. Divide by 3 to get x equals 5 over 3, or 2x plus 3 equals 0. Move the 3 over to get 2x equals minus 3. Divide both sides by 2 to get x equals minus 3 over 2. There they are. Oh, sorry. There they are. Okay, so that is how we solve by factoring, and I hope this adds to your depth of knowledge. Please finish all the rest of the examples on this page, and then there's some homework questions posted to the Google Classroom. Have a nice day, guys. I'll see you soon.